Quantum numbers are values that describe the specific properties of an electron in an atom. There are 4 quantum numbers: the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number.
Each quantum number provides information regarding the location of an electron within the nucleus. The first quantum number is the principal quantum number.
The principal quantum number is a fundamental quantum number that helps define the energy levels of electrons within an atom. It can only take positive integer values like 1, 2, 3, and so on. The maximum value principal quantum number can take is 7.
Which means that maximum number of orbits that can exist inside an atom is 7.
Each energy level corresponds to a specific shell in an atom. As the value of principal quantum number, n, increases, the energy of the electron and its distance from the nucleus both increase. The electron in the first shell is the closest to the nucleus and has the lowest energy. The electrons in the second orbit are further away from the nucleus and hence, will have higher energy than the electrons in the first orbit. An electron is the furthest from the nucleus when it is in the 7th orbit. Electrons in the 7th orbit have the highest possible energy.
The next quantum number is the azimuthal quantum number. Denoted by L, azimuthal quantum number describes the shape of an orbital placed within the main orbit.
An orbit is made of suborbits called orbitals. The azimuthal quantum number represents these orbitals and describes their shape. The azimuthal quantum number specifies the suborbit in which an electron is located, and it ranges from 0 to n-1, where n is the principal quantum number. When the value of the principal quantum number is 1, the value for L is calculated as n-1, which is 0. When principal quantum number is 2, the azimuthal quantum number can take 2 different values. On using the formula n-1, the answer is 1. Thus azimuthal quantum number adopts 2 values. L will be equal to 0 and L will be equal to 1. When principal quantum number is 3, the azimuthal quantum number has 3 values. L equals 0, L equals 1, and L equals 2. When principal quantum number is 4, L equals 0, L equals 1, L equals 2, and L equals 3. The highest value for principal quantum number is 7. When n equals 7, azimuthal quantum number can take 6 values. L equals 0, L equals 1, up to L equals 6. Theoretically, azimuthal quantum number can take any value up to n-1, in practice only 4 values are possible.
L equals 0 corresponds to s orbital. It is spherical in shape. L equals 1 corresponds to p orbital. P orbital has a Dumbbell-like shape. L equals 2 represents d orbital, which is shaped like a double dumbbell. L equals 3 represents f orbitals, which have a very complex shape. When n equals 1 for the first shell, there is only a single orbital within the orbit. It is called the 1s orbital. When n equals 2, L has 2 values, indicating presence of 2 orbitals inside the second orbit. L equals 0 for the 2s orbital, and L equals 1 for the 2p orbital. For the third orbit, n equals 3, L has 3 values. L equals 0 for 3s orbital, L equals 1 for 3p orbital and L equals 2 for 3d orbitals. For the 4th, 5th, 6th and 7th orbits, only 4 values of L are possible. L equals 0, L equals 1, L equals 2 and L equals 3, indicating s, p, d and f orbitals within each orbit.